Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the print in reverse. And for this particular challenge, we are trying to use Java 15 since we don't have Java 7 available and also Java 8 is not available at this moment. And if you want to use something else other than Java, then go ahead. But for this challenge, I'm specifically using this language to solve this one. And we have the public static void function called the reverse print, which is inside the class of the result right here. And as the reference, we have the class called the singly linked list node. And for this node, we have two values. The first one, which is the property. The first one, which is the property of data, which is as the integer data type. And the next one, which is the property called the next. And then we can chain with another singly linked list node class right here. And for this function, reverse print function, it is returning void, and in other words, we are not returning anything from the function. And the parameter, we have one parameter only called the linked list with the L list of the data type of the singly linked list node from the class reference right here. And it says, given a pointer to the head of a singly linked list, print each data value from the reverse list. If the given list is empty, do not print anything. And for this example, we have the head value, or the head linked list node refers to the linked list with data values of 1, 2, and 3 and null. To visualize this, let me draw something using the comments. We have data value of head, since head is pointing to the one of data 1, and then the next one, which is the 2, and the next one with the node contains the data of 3, and the next one is null. Since next one is null, next is represented by the arrow sign right here, and null, and then the next node is not visualized with any node whatsoever. And then we need to print the following from the tree right here, printing reverse using the system out print line. If you are working with JavaScript or TypeScript, then you can simply use the console.log with the node name accessing the data property of the reverse node name. And we need to iterate this in reverse in order to solve this challenge, printing from the last one to the first one instead of the first one. And for the function description, complete the reverse print function in the editor below. And the description right here is already described earlier, and the input format contains t, which is the number of the test cases. The input of each test case is as follows. The first line contains an integer, let me remind you, it is an integer n, and the number of elements in the list. Each of the next n lines contains a data element for a list node, and we have an array or a node of input right here, and also the sample output, that is, I believe it is in the form of reverse one. I still don't understand this one, but this is the explanation. There are 3 test cases. There are no blank lines between test case output. From the constraint right here, there are no blank nodes from the nodes chain. And the first linked list has 5 elements, which is 16, 12, 4, 2, and 5. Printing this in reverse order produces 5 from the back, and then 2, and then 4, 12, and finally the 16. And we need to do the same thing on the second list and also the last list. Okay, so without further ado, let's solve this out. But for the first one, we need to iterate over the current linked list using the linked list head right here, and we need some kind of iterator to as the pointer to traverse over the linked list parameter that already given right here. And for the next one, we need to print the value from the data property from the back of the list up to the point to the first one. And as we iterate over the first one, for the first linked list traverse, along the way we need to store the data property into our variable. That this variable we can use a stack let me introduce you a stack. What is a stack? A stack is a data type or the variable that stores the element starting from the bottom up to the top stack. So it is represent last in and first out. Last in, what is last in and first out? If you happen to insert, let me visualize this. If you happen to insert iterate 1 and then you place 1 at the bottom, let me describe this. Place 1 at the bottom, and then for the next one from the stack you place 2. As we iterate this, you place 2 at the top of the 1, and then the next one, which is 3, and that is the last one, and the next one is null. So of course we only have 3 as our last element. Since it is LIFO, our last in first out, since 3 is the last one, then of course after we popping the stack, or we are removing the element from the stack, it is starting from the top up to the point to the bottom, and then we are popping the 3 from the stack just like an array using the pop method. This documentation has the pop method, I believe. Yes, it is has a pop method, and then the output from the method, which is in the form of element of the data type that we already store from the beginning as we iterate using the pointer from the linked list node. And then in order to store, we can use the push method. So the push takes one parameter, which is the element itself, and it pushes an item onto the top of the stack like I described earlier. It is for the one, we have pushing one into the stack, and that way it is placed on the bottom because it is the first one, and the second one, which is 2 right here, it is placed at the top from the 1, and the last one, which is 3, placed on top of the 2. And then since if we happen to use the pop, then of course we are removing 3 from the stack, and then if we use pop again, we popping 2 from the stack and we return the data 2. And for the last one, we are popping 1 and then we are returning 1 from the method pop. And it is described right here. If we push something of the element, then of course the output, which is the element itself. And if we pop the element, since it's last in first out, then of course if it is 3 on top of the stack, which is the latest one, then of course the pop method that takes no parameter, the output is in a form of element itself from the stack that we already popping currently, and it returns the object at the top of the stack, the last item of the vector object. Since stack is also a data type from the vector branch. And let's solve this out by creating new stack. Let me see the constructor. Let me copy this one. Since it's DQ, then we can use the stack instead of the DQ using the stack that takes the integer data type integer. Since we are working with integer of data property right here, we can name this stack and we construct new stack of the data type integer. And then for the next one, we can declare using the while loop while the linked list is not null. Then of course we iterate the linked list using the linked list equals linked list dot next. And then along the way, before we are pointing to the next one, then of course we are storing the stack using the Stack.push. We can access the linked list dot data, but the linked list itself is pointing to the head only from the function. In order to iterate over the linked list from the 7 right here, and then we are iterating over the 3 and then 9 and then null, we need some kind of pointer using the another single linked list node called the current node that takes the value from the linked list, and that we create a copy of the linked list, and this one is acting as the variable that traverses over the linked list right here. And then we can refactor this one using the Ctrl D to select multiple variable name. Ctrl D again. We can rename this by just typing the current node and check if the current node is not null. Then of course we are pushing the current node dot data, and then after we push, then of course we shift the current node to the current node dot next, accessing the next one from the data. Since it is 1, we are storing the 1 into the stack like this 1, and then current node equals current node dot next. Since it is current node is not equal to null, then of course dot next, which is the next one, and pointing to the 2 node right here, and we are placing the using the stack.push, we are placing 2 on top of the 1, and the next one we are placing 3 on top of 2, and then the while loop will stop because the current node is already null and it reaches the end of the node chain, which is the null node right here. And for the next one, we need something to iterate over the back from the chain of the node up to the first one. And for this one, we can achieve this by using the while loop, while using the stack instead of the current node. Again, using the stack to iterate over the stack like this that we already declare. Then of course we need some method called the check if the stack is not empty. Yes, test if the stack is empty using the empty method, and it's returning either true or false. If it is empty, if it's really empty, then of course it is returning true from the method. If it's not empty, then of course we are returning false if it's not empty. So let's use the while loop while the stack is not empty using the empty right here. Since stack.empty is false, then of course we can reverse this using the exclamation notation in front of the stack.empty method, and that way we are checking while loop while the stack is not empty. Then of course we are iterating the stack itself using the system out print line from the I mentioned this system out print line from the start of this challenge. Using the system out print line to print out the data from the back, and we are tasked to print the following item using the system out print line, and then text instead of the data. Then of course we are using one more method called the pop, and it says removes the object at the top of the stack and returns that object as the value of this function. So the pop method, it is used to remove the tree, and then from the pop method itself it is returning the popped element. So let's say if we are storing 3 as our latest element from the stack, if we use the pop, then of course we are removing 3 from the stack, and then we are returning 3 as the data from the method pop using the stack.pop and takes no parameter. That way we are printing 3 into our system out print line, and at the same time we are popping the element from the stack, which is the 3, and we are not returning anything since it is void from the function. So let's run this code to see if it works, and the while loop will repeat every time until the stack is empty. And let's submit this code, and I believe I have some kind of connection problem because it takes so long to submit the code. Maybe it's because my internet connection. Okay, so it is a success. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. I will happily answer it. Or if you have a better solution regarding this challenge, tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.